Hi, I'm David Wolpert, and I wanted to talk a little bit today about the process that I went through in being able to figure out some geophysics. So, when I was in American River College, I had started to study cloud behavior. Now, cloud behavior is one of those topics that's pretty interesting to me, and it's one that I revisited as I did research when I went throughout the years. So when I first looked at cloud behavior, what I looked at was, and specifically with respect to lightning and thunder, I was looking at the behavior of ionization of particles as they're evaporating from the ocean. So, what causes a particle to, which has been in part of the topics of the videos that I've done, nucleate as it creates ice crystals in the atmosphere as it's going to upper atmosphere. And one of the hypotheses that I had was that it's being bombarded with solar rays while it's increasing in height and changing into from a water vapor into a crystal, and that causes a nucleation around an ion that has a different charge. And then as this ion travels across the troposphere in jet streams, it separates according to charge. And when you get clouds that meet from different regions, you'll have these clouds come together and they'll have different charge, what we call charge densities. And these charge densities will mix, some of the air will collide, you'll have different layering, so you'll have different behaviors of that layering as those particles interact, and you'll get some friction, and then all of a sudden everything melts, and you have all of these charges distributed, and all of a sudden they cascade down, and you get lightning. Now, one of the things that I was looking at with respect to that is cloud chambers. And there are some really cool experiments on the internet with respect to cloud chambers and how they work, and a ion hitting, or a photon hitting a particle in a gaseous cloud state, and you could be able to chart it from where it goes. It's kind of cool, but it doesn't solve all of the problems mathematically. And so I kept looking at different problems. And one of the problems I came across was piezoelectric systems. So piezoelectric is when you deform an object and it has a voltage across surfaces. And when I was working on research, what I noticed was that some of the particles that we were talking about were silica and silica oxide, which is silicate, and SiO3, and it is something that creates quartz or glass. I mean, glass is just silicate molecules. Something like Pyrex would be borosilicate. And if you look at the crust material of the Earth, there's a lot of alumina and silicate particles in the crust. As a matter of fact, that's primarily what the crust is made of. And so what you want to look at is, what is the behavior of those particles when they're in a constrained stress state. So you'll have particles that will be in the position of compression or poling, which is decompression, and you will have different stress states as the Earth is spinning around. And so what you get is a voltage across those surfaces as you have dynamic spinning. Now, this isn't very much, but you have to remember that the Earth is pretty big and the crust is pretty thin compared to the size and the radius of the Earth. And so what you get is a constant voltage across those surfaces. And you have these clouds coming in, and they've got these different charged particles across them. And you get this separation of charge according to the surface charge of the planet. That's the idea. It mathematically, going through it, it's challenging math. It's relatively challenging. It's something called tensor analysis, which is the study of systems with different constraints in a linear fashion. You can go through a whole lot of tensor analysis, and I'm not going through that right now. And what you end up with is an interesting system that essentially it's all set up to have this cascade of electrons and protons. The protons aren't moving very much, but they can move. They can move. They're 2,000 times more massive, but they can move. So what you have is these particles that will respond in these situations, and you have friction, and you also still continue to have solar bombardment. So it's kind of a cool system. It's kind of how all of the things come together and form these really beautiful natural systems that generate voltages through just natural systems that are there. And that, to me, when I can see the symphony of behavior of all the mechanisms at the same time, then I start to recognize how beautiful nature is. And that, to me, is amazing. Anyway, thank you, and have a good day.